almost the same. It's just that we have here limited points. In here, we have a number of points. So as you can see, as we have the values of your vector field F obtained from the given points, so we can see here an increasing length of your vector. As we have also seen in the previous graph where we applied manual graphing or point plotting. So if you're going to sketch some points here, the behavior of your graph will look like this. So it will have here, it goes upward on your first quadrant. Then on your second quadrant, we have the vectors in the direction going to the left. And then in the third quadrant, we have vectors, which is going down. And then in the fourth quadrant, we have vectors which are going to the right. So it forms a circular pattern. So as we can see in the graph using MATLAB, so we have here a circular pattern of vectors, set of vectors. So this is the graph of the vector field f of xy equals negative yi plus xj. Let us have another example. So in here, we're going to sketch f of xy equals xy. So in the first vector field that we have graphed, it is in the form of ij, while here we have in the form of angle bracket. So using an input-output table or table of values, we can show some of the vectors in the vector field. So let's start with the origin. So it is at the point 0, 0. So this will also have the components of your vector field now to be 0, 0. As you can see, we have here written as 0, 0. When we are to assign 1, 0 in your vector field, so this will be in angle bracket form 1, 0 also, because you're going to assign x equals 1 and y equals 0. Then when you have 1, 1 to be substituted in your vector field, the resulting component of your vector field will also be 1, 1. Then if you have 0, 1, so we have now the resulting component of your vector field is also 0, 1. So take note that this coordinates xy is considered as a point, while here, these are the components of your vector field. But we can treat this as your initial point, and this will be your terminal point. And then when you connect these 2 points, it will form a vector. So I hope that you will not get confused on this symbol that we use for point and the components of your vector field. So to continue, we have now the point 1, 2, and then the components of your vector field will also be 1, 2. Then you have negative 1, 0 as the coordinates of your point or xy. So for the components of your vector field, it's also negative 1, 0, and so on and so forth. So if we're going to sketch now, this is how it will look like. So draw your x and y axis. Then let us now plot the points as well as the vector components. So we have here at 0, 0. So therefore, this will also be the components of your vector f, which is 0, 0. When you have 1, 0, 1, 0 is right here. Then you have the components of your vector field to be 1, 0. So we measure from the right, because this is your component 1, then this will be your y component, which is 0. So we measure 1 unit. Let's say this 1 unit. So this will be your initial point and this will be your terminal point. So let us connect these 2 points. So I'll just shade in this manner so that we can see the vector. So then I have the arrow as the symbol for the terminal point. Then you have 1, 1. 1, 1. So we have here 1 and then 1. 1 for x, 1 for y. Then we also have here 1, 1. So we measure 1 unit to the right and 1 unit upward. So this will be the terminal point and this will be the initial point. So let's connect now these 2 points. Then let's put or draw an arrow. Then we have 0, 1. 0, 1 is right here. Then let us plot 0, 1 also for the components of your vector field. So we have 0 for x, then y is 1. So it's like having that this point will move 0, then 1 upward. So let's connect the 2 points. This will now be your terminal point and draw an arrow. Then you have 1, 2. 1, 2. So you have this a while ago as 1 unit. Then it is now 2 units y. So we count 2 units from here. So this is 1, 2, which is the initial point. And then 1, 2 will be a terminal point. So we count 1 unit, then 2 units upward. Then let's connect these 2 points. Then we have negative 1, 0. Negative 1, 0 is right here. Then we have negative 1, 0 as the components of your vector f. So that means you have x is negative 1, then y is 0 also. So it's like that. It's like that. So therefore, if I'm going to connect these 2 points now, so this we have here now the arrow. Next, we have negative 1, 1. So negative 1, 1 is right here. Then we also have negative 1, 1 for the vector component of your vector field. So negative 1, positive 1. So let's connect these 2 points. This will be our terminal point. Then we have 1, negative 1. 1, negative 1 is right here. We measure 1 from the origin, then 1 down, 1 unit downward. And then you have now 1, negative 1 also.
It's 16 hours.
So therefore, we have here 1 unit, then 1 unit downward. So let's connect these 2 points. And take note, this will be an arrow head at the terminal point. Then we have, let's say you have here negative 1, negative 1. So let's use that, negative 1, negative 1. So this will have also negative 1, negative 1. So where is that point, negative 1, negative 1? It's right here. Then I will have negative 1, negative 1 as the components of your vector. So negative 1 to the right, negative 1 downward. Then we have 2, 1. 2, 1, so we have it as 1, 2. This is the terminal point. Then we have 2, 1 also. So we count 2 units. 1, 2. Okay, again, this is 2, 1 rather. This is 2, 1. Then 2, 1 also. So count 2 units. 1, 2, then 1 upward. So let us connect these 2 points. Then we have 2, 2. So 2, 2, we have with us 1, 2, then 2, 2 here. So 1, 2, 1, 2, then 2, 2. So this is your 2, 2 a while ago, then 2, then 2. So we can now see the pattern of your vector field. So it will look like this. So as we assign values here on your xy, we also have the components of your vector. So it will look like somehow like this. So they should be parallel. They should all be parallel. I mean, if you have these vectors in the first quadrant, they are all parallel, but they have different lengths. Likewise here, in the second quadrant, they are they are parallel and then but of different length. Likewise in the third and fourth quadrant. So let us now check graphing this vector field using MATLAB. We have seen the graph of the given vector field f of xy equals xy using the point plotting. So in here, we also have now the command in MATLAB that will graph the given vector field. So this is the graph, and we have here the command. So in this case, I still use the mesh grid command, the cleaver command, but then I change the component of your vector u and vector v. So it says in the vector field given equation as xy. So u equals x and v equals y. So if you notice, the graph also on the left, so we have the same answer as in the manual graphing. So this graph here is the same as what we can see right now using MATLAB. So this is how we sketch vector fields into space. So we have used point plotting and MATLAB.